Okay, alright guys, so this is part 2 of panel upgrade lab. So, first of all, before I get started, objectives are properly upgrade a new panel. Okay, required tools, you're going to need pretty much the same set of tools you needed in the last video. Okay, I'm not going to run through all of those. Safety equipment, you guys already know what you need. Okay, and this lab, you're going to need armored shield ground. Okay, you're going to need 2 ground rods and a cold water as well, and an armored ground clamp, 2 doubles for your main, and 1 single for your cold water. Okay, so 2 for your ground rods, electrodes, and 1 for your single for your cold water, excuse me. 5 half-inch 2 screw non-metallic connectors or Rolex connectors, and this is from the original makeup portion. So why are we reconnecting these circuits back to the new panel? Okay, because on a typical panel upgrade, all right, when you first of all go through the whole business of calling for a meter spot, requesting to unlock the meter, shutting down the power, okay, by permit, keep in mind, your goal is to demo the existing riser, cut the drop, and then take down the old panel. Now when you take down an old panel, there's an old grounding system that's no more useful, okay, because the grounding conductor is smaller. All right, typically our panel upgrades are from 100 to 200. That's what our entire mod is based on, 100 to 200 upgrade. Okay, so before even grounding, all right, you have to explain to your students that the existing circuits, if the location remains in the same spot, are going to have to be reconnected. Okay, so when you are demoing your panel, those circuits have to be, first of all, removed. The panel has to be removed carefully. Okay, they're gonna have set screw connectors, some type of lock nut, bushing, MC connector, maybe flex connector, you never know. Okay, all that has to be removed, okay, and labeled and then reconnected. The reason we're labeling it is because once we install the new panel, those circuits have to go inside of the new panel and be reconnected to the new breakers. Okay, and no, existing circuits do not have to connect to new breakers unless you're extending the circuit. Okay, if you're not extending the branch circuit, which typically you're not going to be, you do not have to install arc fault breakers. All right, so existing breakers, if you have 10 15 amp breakers, your new panel is going to have 10 15 amp breakers. If there's 2 40 amp breakers, 2 pole for the AC units, you're going to have to reconnect those. All right, so you have to buy new 2 pole 40 amp breakers, and then with a label maker, label the panel upon connecting it. Okay, so typically the sub panel that we did the makeup work on, all right, should be linked to a main service panel. That main service panel, all right, you're gonna mount. You're gonna be mounting that service panel, installing a riser, and having your students do the grounding, okay? Because a key part of this is the grounding, okay? And keep in mind, for 200 amp, you have to tell them, lab purposes, we're using the number 6 armored ground, okay, or number 8, but in the field, it's gonna be number 4. Okay, there's no big difference in using the material. For practical lab purposes, it's fine. But I want to see my students be able to link this sub panel, okay, that has 5 circuits on it, link it to the service panel. Okay, now typically, there's not going to be a sub panel. You're going to be reconnecting these circuits in a main service panel. Okay, so 2 parts on the panel upgrade. You have to make sure they understand. In an existing panel, we're going to be taking this down. disconnecting the circuits. Okay, disconnecting the circuits. Okay, so whatever was once connected, it's labeled, okay, will be reconnected into the new panel, okay? And the wires cannot be spliced inside of the panel either. So, again, just to reiterate my point, now the whole point of reconnecting these circuits is for your students to understand that this panel is going to come down. It's going to get de-energized, okay, by a main breaker. All right. Once you de-energize it, of course you have to take out the meter so there's no power. Then you go up and then you cut the service head. All right. That's the job of an electrician. All right. To cut the service, a trained electrician, and you're dealing with live power. Okay. Yes, there is no load on a service drop, but it is still live. You're getting 120 over 240 volts. All right. So de-energized. This panel comes down. All right. You mount the new panel once the grounding is complete. Okay, I don't have grounding here in this lab set up, but you have to set it up in your own lab. Okay, reconnect the circuits after you mount the panel, and your panel has a height. Okay, so when this panel comes out, the new panel has to be maximum 6 foot 3 inches, I believe, and 4 feet 6 or 3 is the minimum to the center of the meter. So this is going to be a meter section, okay, main service panel, and the center of the meter maximum can be 6 feet 3 inches maximum. A rule of thumb to your students, main breaker should always be eye level. Okay, now your point of taking down the old panel and installing a new panel is providing your customer with more juice. Okay, customer, client, GC, or foreman you're working with. Okay, that is the purpose of a panel upgrade. Now, you have to go over grounding with them, reconnecting the circuits, what dedicated branch circuits are, because the mod after this is actually residential, where you're going to go deeper into that. Okay, and there's going to be another panel makeup lab simulating a panel upgrade. Okay, so in detail you have to again explain why you're reconnecting the circuits, why you're doing panel makeup, and then when you're working on your main panel, you should set up your own riser with your own weatherhead and have the students do grounding and link to that main panel as well. Okay, so besides that, I think we're all good for part 2. Okay.